So class, this is an introductory topic on the subject of DSP, that is digital signal processing. So before we proceed further into the subject, I would like to discuss on the books that you should follow. Number one, the book which you have already studied for your signals and systems, that is Signals and Systems by Ramesh Babu. And the second book that will come handy is Digital Signal Processing by the same author, Ramesh Babu. This book has the same topics as your Signals and Systems by Ramesh Babu, but few more topics, especially the filter portion which is in your syllabus in DSP, is included in this book by Ramesh Babu, which is named as Digital Signal Processing. So you will be needing these two books, Signals and Systems and Digital Signal Processing, by the same author, P. Ramesh Babu. So now we can start with the topics. The first question that we would be addressing is, what is a signal? We have already studied what is a signal. In your fourth semester, if you remember, we had a very detailed discussion about signals and systems, right? So, and before we proceed further, I would like to state that you would be needing the concept of signals and systems, the terms, the concept of signals and systems again and again for your DSP, for your understanding of the subject of digital signal processing, because this is a better or a higher version of your signals and systems. So your signals and system must be very thorough before you proceed with your DSP. So to start with, what is a signal? As we know and we have already studied, we all know it. Signal is a function which carries some or which holds some information. So, and function we know is a dependent variable depending on some independent variable. Fine. So if the dependent variable is varying or depending on only a single independent variable, that is, the independent variable is only one. For our instance, it is either time or numbers. Then we call the signal as a single dimensional or one dimensional or 1D signal. But if the independent variable is more than one, maybe two, for example, time, temperature and pressure, any variable which changes with temperature and pressure in a system, then the signal we will be calling as two-dimensional. Likewise, it can be 3D, 4D. Now, major classification of signals. We have already studied, or we all know, the major classifications of signals. These are all repetitions. I am just making you remind your signals and systems in this introductory class. So, to begin, signal is majority of two types, analog and digital. We all know it. Analog signal can further be classified as continuous signal and discrete time signal. Now, what is a continuous signal? continuous signal are defined for every instant of time. That means for every instant of time we will have a certain value of the signal, or you can say x of t. Now comes what is discrete time signal. Discrete time signal is the one where the amplitude is continuous but the time is discretized. For example, or we can say whenever you transmit a continuous signal through a switch which closes after every capital T seconds. That means at the output what we will get is, if you send an x of small t through the sampler or through the switch, at the output what we will get is x of n into capital T, where capital T is the time period. That means after every capital T seconds the switch was closing. That is, the time period of sampling was capital T, and n is an integer which varies from minus infinity to plus infinity. So the output is what is called your discrete time signal. That means whenever we transmit a continuous time signal through a sampler, or which we can also call a switch which closes after every t second, capital T second, what we get at the output is called the discrete time signal, that is x of n capital T. Now comes your true digital signal. A true digital signal is one which is discrete in time and quantized in amplitude. That means, in other words, we can say when we pass a discrete time signal through a analog to digital converter, at the output what we get is a true digital signal. That is, we can say, or mathematically what we do is we round off the discrete time signal. For example, at any instant of time, if we have got the amplitude as say 3.6, then for converting it into a true digital signal, we can round it off. That is, we can quantize it to 4, the next higher level, that is 4. That means anything which is equal to or greater than 0.5 will be rounded off to its higher level, but if it is less than 0.5 it will be rounded off to the previous lower level. So the signal that we will get, that is at the output of the analog to digital converter, is a digital signal. Now, what is signal processing? In the simplest language, if I want to describe the signal processing, is to process a signal or to do any transformation into the signal to get either a desired quality signal or a signal which is better than the previous signal in some way or the other. That means we are processing the signal, doing some work on the signal, doing some transformations on the signal to get a signal which is either our desired signal for some purpose or a signal which is a better quality, or which is better in some way or the other, in some characteristics or the other, than the previous signal which was at the input. Now, why digital signal processing? See, why not? The question can be, why not analog signal processing? Why we are focusing on digital signal processing? We will come to the advantages of digital signal processing in the upcoming slides, but here, if we want to discuss about it, we can say that most of the signals that we encounter in our day-to-day life are actually analog signals. Now, that is the speech that we deliver or the communication that we do, our voice or any audio. That means the most of the things in our day-to-day life are analog. So if we come or we confront analog signals more in our day-to-day life than digital signals, then why would we process or why would we study digital signal processing? Why not we studying analog signal processing? So in digital signal processing, we are not going into the advantages. The advantages are galore when we study digital signal processing, which we will be discussing in the slides later. But here, this block diagram is the diagram of a digital signal processing system, the whole system. This system, this whole block diagram, or you can say the digital signal processing system, can process both analog and digital signals. With this single system, we can analyze or process both an analog signals as well as digital signals. Now, as the signals that we come across are analog signals, so the input will always be x of small t. We are passing it through an anti-aliasing filter. Now, what is this anti-aliasing filter? This is a low-pass filter used to remove the high-frequency noise and to band limit the signal. We will pass this, and we have already studied anti-aliasing filter previously in our signals and systems class. That is why I told you the concept of signals and systems is very important when we want to study digital signal processor. Now, the output of the anti-aliasing filter will be fed to a sample and hold circuit. What will be the sample and hold circuit doing? The sample and hold circuit will hold the output, or you can say will hold the input of the A to D converter at a steady level. That means it will provide the input to the analog to digital converter at a relatively constant level when the conversion of the analog signal to digital format is done. So, the analog and digital converter will get an input which is relatively constant while it is converting the data from analog to digital. That means the sample and hold will hold the value. Now, what the analog to digital converter will do? It will convert the analog signal to digital signal. Now, the output will go to the DSP, that is the digital signal processor. The digital signal processor will do its work, and it is very simple. It is not, the working of a DSP is not a very difficult thing. It is simple, that is, it will only process the signal and give the output to the digital to analog converter. That means again at the output of the DSP, the signal which will be at the output needs to be converted from digital to analog platform. This output of a digital to analog converter will look like somewhat like a staircase. So at the output, it will be fed to a reconstruction filter. The working of the reconstruction filter is very simple. It will just smoothen the staircase like structure into a continuous signal. That means the output of a DAC, that is the digital analog converter, is applied to a reconstruction filter which smoothens it into a continuous signal, and the output we get is y of t. This will be y of small t, which is misprinted as y of capital T. So class, we will be moving into the advantages and the limitations and the application of DSP into our next class. If you have any question, first you have to go through the video, and if you have any question, we will address it in our Google Meet session. Thank you.